So here in your kit is we have a gear pack that we 3D printed, and you should have at least 4 sizes of gears. You might have a few extra gears in there, but your big gear should have 32. Your next one is 24. They basically go down by 8, so we've got 32, 24, 16 little cogs, and 8. So one of the concepts that we're going to explore here is gear ratio, and where students would most likely run into this is particularly on bicycles and other things that might require something to speed up or slow down. Sorry, so usually when you're riding a bike, it'll say you want to gear up or gear down. That's actually changing the chain on whether it's on a bigger or a smaller gear, and you get advantages and disadvantages over different types of or sizes of gears that you use. So in your kit you have these little pegs, and your gears will fit right into the peg. And this is where it takes a little bit of creativity. Let's imagine I wanted my big peg or big gear. I tend to put him on the end, okay, and have him, because that way I can adjust things as it goes around. And then my little gear can be someplace closer to the center or something like that. You know, you have to fiddle with it a little bit to get them placed right. So let's start with my big gear, and I'm going to start with my little gear. So one of the things that we're going to do is we're going to hook them together and we're going to spin them. And what we're going to pay attention to is how fast does the big gear spin in relation to the little gear. And then we're going to turn the little gear, and then we'll turn the big gear and see which one is also easier to turn. So also in your kit, you should have these kind of little blue connectors. These things are primarily designed so that it will be easier for you to turn your gears, because they kind of make little handles. All right, and you should have 2 or 3 or 4 of them or something like that. And they just stack on top of each other. Yeah, kind of like little Legos. So let's put my one gear in here. Okay, make sure that it spins. Okay, so he's happily spinning. I'm gonna put him again toward the edge. And now I'm gonna find a spot to put my other gear and try to line up a hole so that it fits. That's usually the hardest part, is lining up a hole and getting things where it fits. So now I've got my little gear mechanism. I'm gonna take a couple of these guys, put it on my small gear. Alright, and I'm going to put a couple on my bigger gear. Again, this is primarily just so it's easier for me to spin them. Okay, so this has 32 cogs. This one has 8 cogs. So one would think what would happen is that the bigger gear would spin 4 times slower than the little gear. So again, we're sneaking a little bit of math in here for the kids. So when I spin it, what you can do is you can count how long it takes for one cog to go all the way around versus how long it takes for another cog to go around. And what you can do is put a little dot or something with a marker, or even just a little tiny piece of masking tape, and that way you can see how far around each of the little cogs go. Okay. So what I'm going to do is I'm just going to do a little tiny bit of masking tape on one of my cogs there, and then I'm going to do another little tiny piece on another one of my cogs on this side. Okay, and I'm going to get this cog lined up where he's at the start, ready to go. And now as I spin it, you'll notice that my other little cog gets back to the beginning where it started, and my other cog is much further away. It's still got a long way to go before it gets back over here. So that's one turnaround for my small gear. Okay, that's 2 turnarounds. Okay, that's 3. Oh, he's almost back. And this is going to be my 4th turnaround. Alright, and there he is, roughly back to where he started. Right? So it's about 4 turns for my big gear, and 4 turns for my little gear, 1 turn for my big gear, because the big gear's just got a bigger radius to turn around. Okay, Now, when you turn it, take a look at which one is easier to turn. Right? The little gear is a lot easier to turn, okay, than my big gear. Okay? Again, you just got a lot of extra energy that you have to turn, right? Because you have to turn this whole big diameter of this gear versus this one has a very tiny diameter, right? So you can almost think of it as a conservation of energy issue, right? It takes a lot less energy to turn a little gear than it does a big gear. And then you can kind of feel it when you just separate them and you spin one versus the other, right? These fortunately spin pretty well, right? So what we've learned here is a gear ratio. Now the advantage of this is that if I wanted to have something that was, say, big and I wanted to speed it up, I could connect a big gear to a little gear and have that connected to the little gear, and that would speed up the speed of the chain. Okay? And so that's oftentimes when you're gearing up and gearing down in a bicycle, right? If you want the chain to go slower, you actually knock it up to a bigger gear, and then if you want your bike to be able to go faster, you knock it down to a smaller gear. Right? Pretty cool. Okay. So let's go back to our gears. So in our last video we learned about the gear ratio where we've got 32 cogs to 8 cogs. That our bigger one spins slower, right? And the smaller one spins faster. So it's now if we wanted to say, let's go back to our bike analogy, is that bikes are full of gears and we gear up or gear down. Let's imagine that we wanted to get the most power out of our bike. Okay, so the question then is, which gear mechanism would I want to have on my bike? Would I want my chain going around smaller gears, or would I want it to go around faster gears? Well, it's a lot easier to spin a small gear. Okay, and we know that force, and we know that the amount of work that you apply is times force times distance. So we can apply a lot of force, but it doesn't move it around a very big distance. So we're going to do a lot of work, and power is the rate at which we do that work. So power is basically work times time. And when you think about power, power is how quickly you can get yourself to go. So on your bicycle, one of the issues that you want to worry about on maximizing your power to maybe accelerate really quickly is basically how much work you can do and how quickly you can do it. Okay, so again, work is force times distance. So if my chain is at the top, that's going to be my force, and my gear is going to turn. So I've got a force times distance here, which is based on the size of my gear. Okay, so if I can spin this really fast, right, my work is going to be quite a bit higher. Okay, and if I can spin it fast, I can get a lot more power out of using a big gear. Okay, this is going to take a lot of energy on my behalf, right, because I'm spinning a big gear around, right? And you can kind of, kids will have an intuitive sense for that. The bigger something is, the harder for it is to go. But that is how you're going to maximize your power on a bike. That's also sometimes why when you push down on a bike and you really need to get it to move, right, you gear to the bigger gear settings, right? And it's harder to pedal, but you can go more. Whereas if you're in your little gear, right, you're going to be pedaling really, really, really fast to get the same amount of power out.